this is going to be the factory method. So the factory method is used to abstract away or hide away how we are creating an instance of something. It's very similar to this. I'm going to actually make a new class. And I'm just going to copy over, actually, from the polymorphism example from class, this idea here. So we did a very simple version of it, and it basically boils down to you have a method that's static, usually, and it returns the generic type, the abstract type you want to create, and then it returns the specific subclass. Normally you wouldn't pass in an int. We do something a little more special. Take this opportunity to show you an enum. We have cat, we have dog, we have horse. So we're going to change this from an int to an animal type. So an animal type can be one of these values, cat, dog, or horse. And instead of doing ifs, we'll do a switch. Call this type instead. And we will do a case cat. And here we'll do a case for dog. And here we'll do a case for a horse. And then we'll do a default in case it was some unknown animal. That can happen. What happens if later on somebody adds an enum for animal type for bird, and we haven't updated our code here for bird, so that'll catch that. And we also want to do our traditional checking of the parameter for null, because that's not allowed, and that will cause some weird issues if we don't do it. We will get a null pointer exception. Says we can replace it with an enhance switch. Let's see what that does. Yeah, we're not going to do that. I don't want to teach new syntax. So same essential method, right? Before it was, we just took an int, and if it was 0, a cat, 1, a dog, anything else a horse. Now we're a little bit more explicit. We can say if it's a cat, we'll do a cat, dog, dog, horse, horse. Let's actually make this a variable too, so we don't have the same name for everything. So now we can specify out here that we would like a cat named Terry. So now if we run this, yep, it's probably going to run the wrong thing. If we run this, Terry says meow. If we want to make that a dog instead, and a horse, and Terry says nay. So what we've done with this little pattern is simply make this the equivalent to saying new whatever. But we don't have to have this switch or if else or everything littered throughout all of our code. We've shunted it off into one method, which makes our life a lot easier. In addition, if we wanted to change this, and we'll see some more design patterns, how the patterns can build on one another. If we want to change how this is actually created, we just have to do it in one place. We don't have to do it all over the place. So if polymorphism is designed to reduce the number of if statements, the factory method is designed to reduce the number of places where you say new. I'm going to show you a more advanced version of this as well. Just because it is quite useful. It's more complex, but it's very cool. So we're going to steal some of this. But it won't need the enum. Won't need the enum, and we'll just give it a different, actually we don't even need to give it a different name. Now don't worry about the syntax, we will cover it later on. But this is telling us that we want to create this particular kind of class. A class is literally what it sounds like. It's a class in Java. But every class that we type in, right, this main class here, has a class that represents it. And the class.get constructor that takes a string. It's unhappy here because we're throwing the appropriate method, right? So the no such method might mean that there's no such constructor. It doesn't exist. So what we're saying here is from that class, I want to get the constructor that takes a string. So if I'm going to call this, I'm actually going to change this to cat.class. Now, it's unhappy because we're not throwing the exception. Temporarily, I'm just going to that was weird. Did I do that in the wrong order? I did not. There we go. I'm just temporarily so it compiles really quickly. We'll deal with the exceptions afterwards. Main should never actually throw an exception. So this is going to get the constructor from cat that takes a string. So if we go to cat, there is indeed a constructor that takes a string. And we can say new instance. This is just like saying new cat. It's going to have a problem here with a few other things. Illegal access, maybe the constructor is private. Invocation target exception, I actually don't remember what that does. An instantiation exception, there was an issue with it throwing an exception. So that's where your constructor actually throws an exception. And that will actually deal with that. So let's just see if this works. We have to throw the exceptions here too. Again, we'll fix this to be proper, but it will show you the benefit of this. So let's run it and make sure that it works. Terry says meow, make it a dog. We can go one step further. So we can make a variable, pass that in, still work. I got our horse. But now instead of doing this, what I can actually say is class.forName cat. Now this isn't going to work. Because it may not find the class, and in this case it won't find the class, but that's okay. And I'm not entirely sure what the... I think I might just have to do a cast for this. It's been a while since I did this particular thing. Let me do what I wanted. And be lazy. See if there's a better fix. Nope. Guess we're gonna have to do the have to do that. I will look to see if there's a better way to do that. And if there is, I will come back and edit the video. So now we've got our class being a cat. It's not going to work. I'm going to run it. We'll see it fail. And it fails because it can't find the class called cat. Because the class name isn't actually cat. It's actually the full name is the package name as well. So if we go back to our main here, and we put in the package name .cat now, it worked. Terry says meow. I can go one step further with this. I can edit the configuration. And in this case, I'm going to have it say return polymorphism.horse. I think it is upset that I've got two classes with the same name. Or it's upset that this one even exists. And I'm going to, instead of this, I'm going to take argv0, which is the command line arguments. So what I just passed in, right? I just went in here, and I'm passing in polymorphism.horse on the command line. That becomes polymorphism.horse. If I run this, Terry now says nay. So what's really cool here, one thing that's really cool here, is that I can make it so that I put this in a configuration file or something like that, and I can load that file or load that class based solely on the name. What's cool about down here is you'll notice that this is the entire size of the code. If I were to add 100 new animals, this is the entire size of this code. This will have 100 case statements. This is much better from that point of view. So this is a thing called reflection. You lose the type safety because, again, we have to do this class for name. We don't know for sure that, like, if I were to pass in this java.lang.string, right, valid class name, it'll find it, but it won't work. It's going to crash. And the class cast exception because the string is not a kind of animal. So it's all, you get extreme flexibility using the reflection thing, but you wind up with a chance for a mistake if you choose to do it this way. Again, you can just hard code in horse.class, but that makes the code less flexible. Here I can specify completely just the name. Now, I don't want to do this. What I want to do is wrap this. But I may not want to do that either. If we find out, if I'm calling create class in hundreds of places, I'll have to have the same try catch all over the place. So I might find that I don't want to do that either, in which case what I might do is change it so that I do the try catch in here and I just throw a single exception out here that says I had a problem creating an animal. So I'll go ahead and do that because you haven't seen that yet. So in order to do that, I will make a new class. Which is not really an unknown. It's an animal creation exception. Put it in the wrong package. I just have to move it to our factory method. This needs to extend exception. And there's going to be a special thing that we haven't done before with exceptions. This is the one time you're allowed to say throwable. So you can give it, actually we'll call this by its formal name, what it's traditionally called, which is the cause, right? So this is the cause of the exception. This is the exception that actually happened. So what we're going to do is we're going to go to our factory method and we're going to say that this method here throws that. And now we're going to do try catch, and actually I'm not going to do it that way. I'm going to be lazy. I'm going to let the IDE do the work for me. Nope, that's not what I meant to do. I meant to surround it. Nope, don't do that either. I'm going to put this and this into here. And I'll actually move these in here too. You want to do as much work as you can in your try block. And the sketch classes. And then we can use that or there. Right, so we're catching all of those. We're not going to print the stack trace. All we're going to do is we're going to throw a new animal creation exception saying, passing in the class and the exception. Right, so now the cause will be invocation target exception or instantiation exception or legal argument or no such method. Depends on how you want to format it. That's up to you. I like to line things up, as you can see. And we can do the try catch in here. And again, want to move as many things as we can inside of here. Because if it fails, there's no point in trying to call speak on it, right? So there's no reason for that to exist outside of the catch block, or outside of the try block. And we'll just do the or here too. We'll just print out stack trace and see what happens. So we'll run this, it should work. Yep. And I can make a mistake with it just by doing a plus X. And here we go. So it can't find the class, right? Class not found, polymorphism, where's X? So that's fine. And if we change this back to string, and we run it, it'll find it. But we got a class cast exception that is here that yeah, that's ultimately caused by here this assignment. So that didn't it's just the way life is. So let's do one other one, which is we're going to, actually, can I make any? Oh yes, I can make it fail. argv0. So let's run that again, see what it prints out, and I'll show you how to make it fail. So it's a horse. So in the horse class, if we were to come in here and make this constructor private, so nothing else can call it, and now this doesn't compile anymore. We'll just change this to cat temporarily so it compiles. Now it's telling us that horse has private access in polymorphism.horse. Nope, sorry. Again, compiler issue. So I'll make this cat as well. Sorry. So that's not what I expected for the exception. There we go. So now we have that we had a animal creation exception. That we can't create a polymorphism.horse, and the reason, the caused by, that's that exception that we threw in here. Sorry, not there. Yeah, here. Right? We called that the cause. It doesn't have to be called cause, it's just what we generally call it. So it is telling us that the cause was that there's no such method exception. Can't find it, which is odd because you'd think it would be an illegal access exception, but it's not. So that was one way to cause the problem. Another way, it won't work. Actually, it will work. Yes, it will. If I don't make this class public, and I make this public again, Now we get the illegal access exception because we're trying to access a non-public class outside of its package, and that's not allowed. So I just wanted to show you that there's ways to make the mistakes happen. So this is probably what this kind of factory method would look like if you're using reflection. If you're not using reflection, it would just be this regular thing here. Let's go back and fix horse so that it is public again. And I think we had it in here too. Yeah, this should have been horse. And we'll need to import it. So you can only import public classes. Therefore, you can only use them through reflection if they're public as well. So Terry says nay again. And again, if we change Terry back to a cat. Run that. Terry says meow. So again, this one works out just fine, no problem with it. You have the ability to specify any number of them. You just have to have a different switch, a case statement for each one. Using the reflection one, you have the added hassle somewhere along the lines of making this class. We could also do it this way. If we wanted to hide it, to make life a little easier for people, so that we don't have to continually call this. And then we're just going to call the create animal, passing in the class. So this is a good use of method overloading. So I can call create animal, passing in a string for the class name and a string for the name, or a class for the class and a string for the name. Right? They're both just called create animal though. So here I'm going to have to catch class not found exception and throw a new animal creation exception. And we'll have to deal with that in a second. So this is a problem with my animal creation exception where it accepts an actual class. I'm going to change this to be the string of the class name. And this is something that you'll find out that happens periodically. That as you go about doing things, you find that things are not optimal. They worked one way, but you want to change it later on to make it more flexible or whatever, and that's exactly what I'm doing here. Here, we're going to do the class get canonical name here. So if we only have the class name, we'll get the string. If we only have the string, we'll get the class name. Can't get a class if I couldn't do class for name on it, right? So I'd be missing the ability to do that. still works. So now that you've watched this whole video, and I will mention it to you beforehand, you really only need to watch up to the first part where we had the switch. That's the easy way to understand it. You don't have to do this reflection stuff. Obviously, we did it without it. But this shows you a few things. One, it shows you this idea of reflection, which is actually quite useful. It's a bit more advanced with the exception handling. And it shows you how to layer methods. So this method calls that method. You can do with this as little or as much as you wish. If you can wrap your head only around this one, that's all you need to know. I'm not going to explicitly ever test you on reflection or anything like that, but it's quite useful. And if you don't know about it, you're limited. So like I said, you can read these class names from a configuration file, for example, which means that you can change the way your program works just by changing a text file. That's quite powerful. And that will be it for the abstract factory. It is really, I know I've made it very complex, but it is really just as simple as this switch statement.